Hello, students. Today we'll go over chapter 28, which is the search for extraterrestrial life. The picture that you see in the background of this slide, this is a picture of pink eyeless worms, which are found in the underwater yellow mound of yellow solid methane. The purpose of showing this picture is that in order to find extraterrestrial life, first we should find alien life forms on Earth, meaning that we should find uh, life forms or life which lives in very different kinds of conditions that we are used to, or which have very different characteristics. So usually living things live in air or in water, not in solids, but these are things that live in a solid uh, yellow yellow mound of solid yellow methane. So that's an example. Now, what is it that defines life? So on Earth, there are various characteristics of living things which you might have learned in a biology class, such as respiration, reproduction, etc. From the point of view of physics and chemistry, it is organic compounds. So um, living things are made up of very, very complex long chain molecules, and those are called organic molecules. The characteristics of organic molecules are that they are made from carbon, oxygen, and hydrogen. Especially carbon is very important. Carbon forms the backbone of these long chain molecules. So we say that our the life on Earth is carbon-based life. And it is because carbon has a very special property. It can make four bonds. For example, if we look at the um, linear molecule on the top, there are many other um, atoms which can form two bonds. The two bonds, as long as they are connected with uh, other atoms able to form two bonds, they'll make a chain. But the moment it connects to a single bond atom, the chain will break and it will stop. So it will not make very long chains, and it will not make complex molecules, which is what is needed for life. However, carbon, which can make four bonds, it can have chain, and as well as it can connect to oxygen and hydroxyl groups. And these are what forms the complex uh, molecules of carbon, the organic molecules. So Earth is a carbon-based life. There's only one other atom which has similar properties of making four bonds, and that is silicon. So there is some hope that one day we might find a silicon-based life form. However, we have not found one yet. And the reason for that is that silicon, the silicon compounds, the way they exist, they are either too soft or they are too hard, like the quartz rock. And so both of those situations are not suitable for formation of life. So how do we study um, the life? In order to find extraterrestrial life, first we have to understand how life originated on Earth. And it is thought by many scientists that the organic molecules which are needed uh, for the growth of life, for the origin of life on Earth, were actually brought to Earth from outside, from some from some asteroids or some meteorites. In fact, we can find examples of such meteorites. There are some meteorites, a kind of meteorite that falls on Earth, that have been found is carbonaceous chondrite. And these carbonaceous chondrite have these carbon-based organic molecule, which are very similar to the kinds of molecules that would be necessary for the origin of life. Carbonaceous chondrite are primitive meteorites that date back to the very beginning of the solar system. That's when they were formed. This sample is a piece of Elend meteorite, a large carbonaceous chondrite that fell in Mexico in 1969. So because of studying this and because of finding these carbonaceous chondrite, it is thought that some meteorite brought the necessary molecules to Earth to produce life. This is a close-up of the carbonaceous chondrite, and it points to especially special parts where those molecules are present. Chemical analysis of newly fallen specimens disclose that they are rich in organic molecules, many of which are the chemical building blocks of life. So that's one theory. There's another theory that was popular earlier, and there is still some belief in that theory, and that is that uh, the organic molecules could have formed starting from the very basic, common fundamental uh, compounds that are present at many places in the solar system. And this was proved by the Miller-Urey experiment. Those are the names of the two scientists who did that experiment first. Many versions of this experiment have been done, and it has been updated. A new form of this experiment, what it does is it puts together uh, water vapor, carbon dioxide, nitrogen, and hydrogen. These are the gases. These are the substances that are known to have been present in extensive amounts in the um, early atmosphere of the Earth, and then it is subjected uh, to electric sparks, which would be like the lightning that would have been also present uh, quite a bit in the early Earth, and that we know that those happen. Lightning happens in other planets also. So by setting up this experiment, having the water vapor, carbon dioxide, hydrogen, nitrogen, and subjecting it to electric spark caused formation of organic molecules, which proved that a similar process could have happened on Earth in the early times, from which organic molecules are formed and later on life was developed. Another aspect of extraterrestrial life is to look for presence of life on Mars. Mars is our closest planet, and it has conditions very similar to the Earth. So, uh, and it doesn't have very extreme conditions. Unlike Venus, Venus is very hot. It is the hottest planet. Mercury is very hot as well. And then the other planets are gas giants. So Mars is the best candidate. So we have sent these various probes to Mars, and um, there were a bunch of experiments that were done on the soil of Mars to find if either life is present in the soil of Mars now, or if there was life present on Mars in the ancient times. So both kinds of experiments have been done. This is a picture of the Viking lander. This view from Viking lander spacecraft shows the mechanical arm with its small scoop against the background of Martian terrain. The scoop was able to dig about 30 centimeters beneath the surface and get the soil and do a few experiments like gas exchange experiment, the pyrolytic graphite experiment, and um, photosynthesis experiment. However, there were no conclusive results found. So then the next aspect of finding life is to find if there is water on Mars. And if there is water on Mars, then those would be the likely places to look for presence of life. So this is what we know about water on Mars. There is some frozen water that is found on the Martian South Pole. And this we know by doing different kinds of imaging. Um, this is the infrared image and the visible light image. The visible light image shows the south polar cap of Mars, but does not indicate the chemical composition. But by using a camera tuned to different wavelengths of infrared light, the Mars Express spacecraft was able to identify distinctive reflections of an upper layer of carbon dioxide ice and a deeper layer of water ice. So um, there is H2O present on the Mars, but it is in the frozen solid form. So still not very suitable for life. However, there is water. There is also evidence of ancient Martian water. It is thought that there was liquid flowing water in ancient times, and that gives more credence to the theory that there might have been life on it in ancient times. Some of the evidences of ancient Martian water are the sedimentary structures, such as the ones which form sedimentary rocks on Earth. Okay. Um, the Mars rover Opportunity photographed these sedimentary layers in a region called Meridiani Planum. Some of the layers are made of dust deposited by Martian winds, but others were laid down by minerals that precipitated out of standing water. There are also other kinds of substances present, especially millimeter-sized spheres of gray hematite, which we know from Earth, from our experience on Earth, that such spheres naturally form in water-soaked deposits. Talking about the presence of life on Mars, before we sent the probes and did the experiments, there was actually quite a strong belief and hope that there is a very well-developed civilization on on Mars. Um, this belief started from an astronomer in the 1800s who looked through a very basic telescope and saw some structures which he thought were an extensive network of irrigation canals. And so he obviously thought that there is a very well-developed civilization, industrially advanced civilization on Mars. And since then, many other writers and scientists had expanded on that theory, thinking that there were living beings on Mars. Sometimes these kinds of things can happen. We can look at something and our imagination um, can make us believe something that's not there. For example, here is a picture of a face on Mars, which was thought was made by uh, aliens living on Mars. However, this was just a very fuzzy picture taken in 1976 from Viking Orbiter 1. And then later on, with a much more powerful high resolution camera, when the same picture was taken, it was seen that it is um, just an eroded hill and nothing special about it. In the next picture, there is another interesting feature. This MGS image shows features of natural origin within a 215-kilometer wide crater on Mars. It looks like a smiley face. Someone who is more inclined to believe might think that some civilization, intelligent civilization, intentionally made this. There was a meteorite which was again very much in the picture, um, very much in talks as far as uh, the subject of alien life. This 1.9 kg meteorite known as ALH 84001 formed on Mars. It was found on Earth, and we know that it came from Mars. So there was some collision, a huge collision on Mars from some uh, huge meteorite falling on it, which broke away chunks of Mars, and those got away from Mars, kept orbiting in the solar system, and then somehow got in the gravity of Earth and fell on Earth. By doing various analysis, scientists know that this came from Mars. Um, by comparing the gases trapped in the bubbles inside the rock. About 16 million years ago, a massive impact blasted it into space, where it drifted in orbit around the sun until landing in Antarctica 13,000 years ago. So the interesting thing about this is that when it was looked at under microscope, there were seen these structures, these fossils, which looked like some living organisms. These shows structures, tubular structures about 100 nanometers in length found with the Martian meteorite. One controversial interpretation is that these are fossils of microorganisms that lived on Mars billions of years ago. But the interesting thing is that these are uh, nanometer sized, which is about 1,000 times smaller than microorganisms. And it is scientists believe that uh, organisms of that size cannot exist. Another aspect of searching for life is looking in places where it is even possible to have a life. So looking for habitable zones. It's better to look carefully in those zones rather than just generally look everywhere. So those habitable zones are also called Goldilocks zones because they are kind of a medium type of environment, not too hot, not too cold, not too close to the dear star, not too far away from dear star. For example, in our solar system, there is a habitable zone which is around the Earth, and Mars partially falls into that. Similarly, there is a habitable zone or a ring around the galaxies where it is more likely for life to evolve. For regions that are too close to the center of the galaxy, the stars are very much more active. There are many supernova explosions and neutron star explosions, which would not allow life to exist. And then too far away, there wouldn't be the complex chemical substances needed to form life. So there is a habitable zone within solar systems, stellar systems, and within galaxies. One project that has been going on has been to listen for signals uh, from alien civilizations. And we've been listening using using radio waves. And the interesting thing is that there is a certain range of radio frequencies to which the Earth's atmosphere is very transparent. It lets it get through, and we are able to easily hear it. Beyond that, on the higher side and on the lower side, there's too much noise. So we have been listening in this 1,000 to 10,000 megahertz zone and listening for any uh, special signals that might come from aliens. We also look for extrasolar planets, meaning planets that go around other stars. And we try to identify Earth-like planets which may have life on it. And one of the essential components that could lead to life is the presence of an atmosphere. So how do we detect atmosphere? We look at the planet and look at its spectrum. And if there are dips in certain places, those are the uh, signature of the presence of an atmosphere. And depending on where those dips are present, those are because of the absorption spectrum. Those are because of the absorption by the gases present in that atmosphere. And if the right kinds of gases, such as H2O, water vapor, and oxygen, etc., are present, then we suspect that there might be life there. And then we look at those planets more carefully. The last topic in this chapter is about our own search to make contact with alien life. Some of the uh, Pioneer spacecrafts that we have sent, they contain these gold plated discs with several pieces of information about our civilization, about our Earth's location with respect to the surrounding stars, etc., etc. These were sent in a hope that if an alien civilization will find it, then they will contact us. However, more uh, recently, there has been some concern that it is not a great idea to advertise our presence, because if an alien civilization does find this and is able to locate it, we don't know if that alien civilization will be friendly or hostile. So there's different views about it. Anyway, that concludes the coverage of the different topics that we wanted to discuss about the extraterrestrial life.